Greetings to everyone. The topic of our video today pertains to the remarkable survival strategies of Homo sapiens during the Laschamps Geomagnetic Excursion 41,000 years ago. This event, marked by a drastic weakening of Earth's magnetic field, allowed harmful solar radiation to penetrate the atmosphere, challenging early human populations in Europe. New research from the University of Michigan reveals how tailored clothing, ochre-based sunscreen, and cave dwellings may have shielded Homo sapiens from these cosmic rays, potentially giving them an edge over Neanderthals, who vanished around 40,000 years ago. The study's three-dimensional models show how auroras wandered globally, correlating with human behavioral changes. This fascinating interplay of geophysics and anthropology sheds light on human resilience and its implications for modern technology and exoplanetary life. Without further delay, let us delve into our discussion. Picture Earth 41,000 years ago, a planet under siege by cosmic forces. The magnetic North Pole, restless, drifts over Europe, part of a grand dance of poles attempting to swap places, a phenomenon that has occurred some 180 times in Earth's deep history. This was the Laschamps Excursion, a fleeting yet fierce geomagnetic upheaval. The magnetic field dwindled to a mere 10% of its modern strength, its protective halo faltering. Harmful ultraviolet rays and cosmic radiation poured through, painting auroras across skies from Europe to northern Africa. Homo sapiens, those ingenious early humans, faced this celestial storm. Arriving in Europe around 56,000 years ago, they coexisted with Neanderthals, who faded from the record by 40,000 years ago. What secrets did Homo sapiens wield to outlast their kin? The University of Michigan's pioneering study, published in Science Advances, unveils clues. Led by experts in engineering and anthropology, the research suggests tailored clothing, ochre as a sunscreen, and caves as sanctuaries were their shields. Tailored garments, stitched with bone needles and awls, were a hallmark of Homo sapiens unearthed at their archaeological sites. Unlike Neanderthals' simpler draped cloaks, these fitted clothes offered warmth, enabling longer treks for food in frigid climates. Protection from solar radiation was an unexpected boon. Ultraviolet rays, unfiltered by a weakened magnetic field, threatened ocular damage and folate depletion, risking birth defects. Garments cloaked their skin, a barrier against the sun's wrath. Ochre, that earthy iron oxide pigment, emerged as a hero. Slathered on skin, it acted as a potent sunscreen, its efficacy proven in modern tests and echoed in ethnographic traditions. Around 41,000 years ago, Homo sapiens intensified ochre use, adorning bodies and caves. This wasn't mere decoration. It was survival. The Aurignacian toolkit, linked to these modern humans, brimmed with ochre and sewing tools, marking a cultural leap during the excursion's peak. Caves, too, played a starring role. As the magnetic field's collapse let cosmic rays bombard Earth, these natural refuges shielded early humans. The study, led by Agnit Mukhopadhyay, a University of Michigan research affiliate, mapped regions where the magnetic field failed, allowing radiation to reach the ground. These zones aligned strikingly with sites of early human activity from 41,000 to 39,000 years before present. Caves, alongside ochre and clothing, formed a triad of defense, fostering Homo sapiens spread across Europe and Asia as Neanderthals waned. How do we glimpse this ancient drama? Mukhopadhyay, collaborating with Sanja Panowska of Germany's GFZ Helmholtz Center, crafted a three-dimensional model of Earth's geospace. Using the space weather modeling framework from the University of Michigan's Center for Space Environment Modeling, they wove together three models, one reconstructing the Laschamps geomagnetic field, another simulating the surrounding plasma environment, and a third predicting auroral displays. The result? A vivid portrait of a shrunken magnetosphere. its dayside boundary just 15,500 kilometers from Earth's surface, and magnetic poles drooping toward the equator. This model revealed auroras wandering far from their polar homes. In Phase A, 42,153 years ago, the northern hemisphere's auroral oval swept from the Arctic to northwestern Sahara, while the southern hemispheres danced over Australia and New Zealand. By Phase B, 40,977 years ago, a non-dipolar field spawned multiple weak poles scattering auroras globally. The open-closed field line boundary swelled, with the auroral oval's diameter ballooning to 8,167 kilometers, far beyond today's 3,000 kilometers under calm solar winds. Anthropological echoes. Raven Garvey, an anthropology professor at the University of Michigan, highlights the timing. The Laschamps Excursion, spanning 41,000 to 39,000 years before present, coincided with Homo sapiens' cultural strides. The Aurignacian complex, evident by 43,000 years ago, included tailored clothing and ochre, suggesting adaptive responses to radiation. Intriguingly, this period also saw the dawn of representational cave art in Borneo, Australia, and Sulawesi. Alongside portable art and musical instruments, high-altitude sites in Ethiopia and Tibet, occupied during the excursion, hint at humanity's bold reach. Neanderthals, lacking these innovations, faced a harsher fate. Their decline, though complex, may tie to inferior photoprotection. Both species bore pigmented skin, yet Homo sapiens' tailored attire and ochre likely offered superior defense against ultraviolet radiation's perils: sunburn, blindness, and lethal melanomas. These tools, per Garvey, granted access to resources in radiation-soaked landscapes, a competitive edge in a volatile climate. Lessons for today and beyond. Imagine such an event today. Catastrophe looms. Communication satellites orbiting 42,000 kilometers up would face relentless cosmic barrages, risking failure without robust shielding. Terrestrial telecom arrays would falter, navigation systems waver. Mukhopadhyay warns of blackouts across sectors, amplified by even minor space weather. The geomagnetic field's recent 1% decline every 20 years signals vigilance, not panic, as poles tilt subtly. Yet there's hope in this ancient tale. Life thrived despite a frail magnetic shield, challenging notions that strong fields are vital for habitability. This perspective, Mukhopadhyay notes, reshapes exoplanetary science. Earth, 41,000 years ago, was a testing ground for resilience, its lessons echoing in our quest for life among the stars. A correlational canvas. Garvey cautions. These findings weave correlation, not causation. A meta-analysis. Their work reimagines existing data through the Laschamps lens, offering fresh insight. It's a vibrant tapestry of geophysics and anthropology, blending models with archaeological traces. The study's co-authors, Michael Liamone, Daniel Welling, Austin Brenner, Natalia Ganjushkina, Ilya Usoskin, and Mikhail Balakin, bridge disciplines, illuminating Earth's past and future. Closing thoughts. The Laschamps Excursion, a fleeting cosmic waltz, reshaped Earth's skies and human fates. Homo sapiens, armed with ingenuity, turned caves, clothes, and ochre into bulwarks against a radiant foe. Their story, etched in three-dimensional models and ancient artifacts, whispers of adaptability. As we ponder future excursions or alien worlds, let this saga inspire awe and preparedness. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons.